Now, in some of these problems, or puzzles, as they are looking like they are, sometimes the left and right side, there's really no distinguishable difference between the two. They both look equally complicated. And it also looks like sometimes I might do something like rationalize the denominator, or something that reminds me of how we used to rationalize the denominator. So what I mean by that is, let's look at this problem right here, and I'm going to work at the left side and just try to get it to look like the side on the right. Again, that's all we're trying to do, is get both sides to look alike. And when we do that, we can verify the identity. So on this first one, the right or left side is sine x over 1 plus cosine. What we've done in rationalizing the denominators, I'm going to multiply it by a clever version of 1, but it's going to be the conjugate. In doing that, the denominator then becomes the difference of two squares. So this becomes 1 minus cosine squared of x in the denominator, and the numerator is 1 minus cosine x times sine x. All right, what can we do next, guys? Can we cancel out and factor out this 1 minus cosine x with this 1 minus cosine squared of x? Yeah, you're right. We can't do that because we can only do that if they're exactly alike terms, not closely almost alike terms. 1 minus cosine squared of x gets back to this identity. So if I were to subtract cosine squared from both sides, I would get 1 minus cosine x equals sine squared of x. So it looks like I have 1, my numerator, and then my denominator, 1 minus cosine squared, is sine squared. From there, it looks like I have a sign in the numerator and one sign and two signs in the denominator, so I can factor out 1 there and 1 there. Clean that on up, and then it looks like I was able to match the other side. And when we're able to match the other side, we can celebrate and say, identity verified.